Good afternoon, and welcome to this lecture of communication of semester 5. Today we have starting with some of the portions of modulation, right? So just we'll brush it up. What is modulation? Yesterday we had talked about the modulation techniques. That is for communication. So to transmit a single sine wave or say wave, electromagnetic wave through a larger distance, we require modulation so that we can mix it with a higher frequency. We'll study that in depth today, and we'll be continuing with the other modulation techniques, that is amplitude modulation, frequency modulation, and say phase modulation on that note. So we'll be completing all those in this coming lectures. Let me share my presentation with you. I guess my presentation is visible to you all, and uh, is it visible? Is it visible now? Hello. So let me introduce myself. Dr. N.D. Mishram, Head and Associate Professor, Department of Electronics, Sri Mathura Das Mohta College of Science, Nagpur. And today we are going to study more about the modulation techniques that we are using. So we'll just wind up. I would like to introduce today what is modulation actually and why it is being broadly used. Still, it is nowadays it is absolute, because we are having digital techniques for communication, right? So we need to study this. This is in our syllabus of semester 5 of RTM Nagpur University, Nagpur. So we'll begin with that. So we are going to study about the modulation technique. Now, what is say the modulation? So there are different sorts of transmission techniques that we are using. So we are having these electronic communication systems. One is called as unidirectional, directional, unidirectional, bidirectional communication. So we have studied this simplex, half duplex, and full duplex. In simplex, only one-way communication is possible, so that we can only transmit. The examples are radio and television, where we are able to see only, or where we are able to hear only, right? So that is the simplest form of communication, that is simplex system. Half duplex means we can communicate a signal, whether we can transmit or whether we can receive it at a time. So that is for called as the half duplex, whereas in full duplex we can receive as well as transmit the information. So this is all about the unidirectional and bidirectional communication, simplex, half duplex, and full duplex that we have studied earlier. Then the nature of information signal that we are having. So we are having analog signal as well as a digital signal. So accordingly, we can again differentiate the communication system. So we'll have an analog signal and a digital signal. Then the other techniques of transmission, according to the techniques of transmission, we are having the baseband transmission, then broadband communication, and the communication using modulation. So we are going to study this portion of it today. We have completed almost all sorts of communication system. Today we are going to see what is communication using modulation, right? So let us start with that. What is baseband communication? We have studied the electrical equivalent of original information. Information is known as the baseband communication, baseband signal. The communication system in which the baseband signals are transmitted directly is known as baseband transmission. Now, the electrical equivalent of original information, what it implies, it means that whatever I am speaking today in front of you, that is the original signal, original voice of mine. Now, if this signal is transmitted in the same manner that I'm trying to tell you, then it is called as the baseband signal, right? So this is the baseband signal, and the transmission in that part is called as the baseband transmission, which can be directly transmitted. So this can be directly transmitted, that is called as baseband transmission. Now the baseband transmission is effective only for wire communication. As you know that telephone wires on which we call, so telephone lines are called as the baseband transmission, and these are examples. Network data communication, where we can communicate the data of one computer to the other computer, or say in that case we can print the data from computer to the printer. So the data is being transferred. So the data is being transferred through wires, and therefore these are called as the baseband transmission, right? So this is the one of the type of transmission. Then it is inefficient because of for wireless or radio communication. So we cannot travel a larger distance. To travel larger distance, we require the radio communication or a wireless communication, right? So this is the baseband communication. Then limitations of say the baseband transmission. that we are having baseband signals having small frequency range that starts from 20 hertz to 20 kilohertz only. So no large channel accommodation or mixing of signals are there. So more signals cannot be kept on that. So that is the limitation of baseband communication. And due to small frequency range, baseband signal cannot travel long distance in free space or air. So whatever I am speaking in front of you is will go on reducing, the strength of it will go on reducing after a certain distance when it travels a distance, and it cannot be heard at a larger distance. So that is the main drawback of this baseband communication. So after a travel of short distance, signal gets suppressed, so not used for radio communication, that is wireless communication. So it is impossible to transmit the data through wireless or say in the space, right? And to make the baseband signal efficient for radio communication, modulation technique is used. Now this modulation means we are mixing with the higher frequency. Now what is the concept of modulation that we need to study? So what is the modulation? What are the modulation techniques that we are using? We were using. So actually, what is modulation that we can study? To overcome the drawback of the baseband signals, baseband transmissions, and to transmit baseband signals by radio, modulation techniques must be used. So to transmit in the signal in air or in space, the modulation techniques are being broadly used, right? So the baseband signal or the information signal is a low frequency signal, and that cannot travel a longer distance. Just like we cannot walk at longer distance, similarly, the signal also cannot be transmitted to a longer distance. So फिर हम लोग उसके लिए क्या करते हैं? That is what we need to study. What is the definition of modulation? Now, the modulation is the process of superimposing. Remember this. That is nothing but mixing. So modulation is the process of superimposing low frequency information signal, which is called as the baseband signal, on a high frequency signal, high frequency carrier signal. So remember this, we are having a higher frequency and we are going to trying to superimpose the lower or the baseband signal into the higher frequency, so that what happens, it can travel to a larger distance. The strength of the signal remains as it is. Okay, so that is the main definition of the modulation. So modulation is basically the process of superimposing low frequency information signal, or in that case we can call it as low frequency baseband signal, on a high frequency carrier signal. Now this high frequency is supposed to be carrying this lower frequency to a larger distance. That is why it is called as the carrier signal. Okay, so I will repeat the definition again for you. The modulation is the process of superimposing low frequency information signal on a high frequency carrier signal, right? So that is called as the modulation. Now, what is actually the modulation that can be understood by this example? Yeah, I guess this is visible to you. So modulation, say this is a human being, and this is the baseband signal that we need to transfer, right? So he cannot walk a larger distance. So what we do, we use a carrier wave, that is a car, right? So if you superimpose this lower frequency or a baseband frequency, baseband signal on this higher frequency, that is a car, so we can have this type of a modulation, right? So this is called as the modulation technique. Now what we are doing, again I can explain you. So we have a baseband signal. So this is a baseband signal. He cannot walk a larger distance because of his strength. So what we do, we will have a carrier frequency which is a higher frequency, right? And we will superimpose it, means we will mix this lower frequency or a baseband signal into a higher frequency, so that it can travel a larger distance, and he will not get he will not become say restless, right? So the strength of this signal will remain as it is, and we can travel a larger distance. So this is the basic example where we can understand how a lower frequency or a baseband signal that we need to transfer can be can be able to transfer at a larger distance, right, by using this carrier. So I guess you have understood this, the basic concept of the higher frequency and the lower frequency over here. So this is the voice signal that I'm talking is called as the baseband or a lower frequency, and the higher frequency which is going to carry this frequency is called as the carrier signal. Okay, So this was the modulation technique. This is the modulating signal that we were talking. The frequency of which is very low, and this is the information that we are having. And this is the carrier frequency, which is having a high frequency, as you are able to see large number of waves in that particular duration of time. Okay, so it is a higher frequency and we call it as a carrier. And when we superimpose it, so some of the parameter of this modulating signal goes varying, right? So the carrier wave is going to change and the signal is inside it. Okay, now you are able to see that the variation of this modulating signal is going to vary this amplitude, right? So this amplitude is varying according to the uh, wave, a modulating signal, and this is called as the amplitude modulation. And this is the modulated signal. When a man sits in the car, becomes a modulated signal. So this is the basic example how we are going to modulate a signal. So this is the amplitude modulation. We are having three types of modulation: amplitude modulation, frequency modulation, and the phase modulation, right? So we'll be studying this three and we'll be comparing those three also, right? So this is the basic example, what I mean to say when we say that we are going to have a modulation, right? So we are having a modulating signal, that is this information that is to be sent, and the higher frequency, that is the carrier wave, which is going to carry this modulating signal, because it alone cannot travel to a larger distance, right? So to make it to travel a larger distance, we require some of the carrier wave, right? So that is a car over here. And then when a man sits in this car, it becomes a modulated signal, right? So modulated signal when the car and when the higher frequency and lower frequency are superimposed on each other, so then we call it as the modulation, right? Here it is shown that it is actually a carrier, it is amplitude modulation, okay? But we are having three types of modulation also. So we'll study one by one. Okay, so modulation techniques. So this is that modulating signal, and you're able to see that the wave, according to the instantaneous amplitude of this modulating signal, the modulated amplitude modulated wave is being coming up, right? So depending on that, we'll having the change in the amplitude. And this is what is called as the amplitude modulation. We'll be studying this in depth, right? So just for information, I'm telling you this. And these are some of the techniques that we are using. So we are having this electronic communication, we are having analog communication systems, in which we are having continuous wave systems and pulse modulations. So in continuous wave, we are having three types of modulation: amplitude modulation, frequency modulation, and phase modulation, AM, FM, and PM. In pulse modulation, same in analog communication, we are having PAM, pulse amplitude modulation, PWM, that is pulse width modulation, and PPM, that is pulse position modulation, right? So these are all the analog sorts of communication. And in digital communication, we are having PCM, pulse code modulation, then we are having ADM, DM, these types of modulation, digital modulation, and then analog to digital modulation that we are having. So we are having all sorts of communication, different types of communication. In this portion, we are concerned basically with this three types of modulation, that is amplitude modulation, frequency modulation, and phase modulation. We'll study this in depth in the coming classes also, right? So yes, let us again study why we require why we require the modulation, right? So the baseband signal transmission cannot be used for radio communication. To transmit the baseband signal for radio communication, modulation must be used, right? And modulation is necessary because of the following advantages. So this we have studied in the last class itself, but we'll again just revise it. So reduction in the height of the antenna, we have seen how the height of the antenna can be reduced. Then avoids mixing of the signal. And third one, increases the range of communication. Fourth one, multiplexing is possible. Many of the signals can be transmitted through one channel itself, and improves quality of reception. At the receiving end, the strength of the signal that is being transmitted is also improved. So we'll see this one by one. So what I mean reduction of in the size of the antenna is, according to this problem, if the frequency of wave to be transmitted is say 15 kilohertz, that is 15 into 10 raised to power 3, then uh, 50, that is 15 kilohertz if we need to transfer, then the wavelength lambda will be equals to the velocity of light divided by the modulated wave frequency. So we are having 3 into 10 raised to power 8 divided by 15 into 10 raised to power 3, and we get around, say it is around 5,000 meters, right? So this is the 5,000 meters, that is approximately equal to 5 kilometers. Now, if you need to transmit a data through an antenna which is approximately equal to 5 kilometers, which is practically impossible. So this is why we require that as you go on increasing the frequency, the size of the antenna gets reduced, right? So for this frequency, we require a 5 kilometer antenna. So what we do, will increase the frequency, and we have seen this in the last lecture, that if you increase it to say just to 15 megahertz, then the size of antenna is around say 5 meters, which is very convenient, right? So 5 meters, I guess it is approximately equal to the length of the sari, right? So say approximately equal to length of the sari. That is very convenient to build an antenna. So this is how if you use this skywave propagation from say ranging from 2 megahertz to 40 megahertz, the size of antenna can be reduced accordingly. So this is the main advantage of using modulation. Then the second advantage is to avoid the mixing of the signal, mixing of the other signals. So if you have three signals, broadband signals, which are having say frequency range from 20 hertz to 20 kilohertz, so we can transmit the data from say 3 megahertz, 2 megahertz, or 1 megahertz. So we can have these ranges, and we can use these three carrier waves to transmit the data through same single channel. So we are using the same channel, but we are going to use different carrier frequencies of say around 3 megahertz, 2 megahertz, and 1 megahertz accordingly. And this will not get mixed up, right? So the same channel can be used to transmit the data. Whereas if you consider the wired communication, you cannot transmit more than one one information at a time, which implies that there is a mixing of a signal. If you try to send two or more signals through the same channel, through the wires, it is very difficult to transmit, because it is not possible to transmit one or more or two or more signals through the same wire at the same time. But in skywave propagation, it is possible, because we can use different types of different frequencies of carrier frequencies, and accordingly we can transmit this different two or three, or say more than hundreds of signals through the same channel using different carrier frequencies. And at the receiving end, we will be using the same sorts of signals, right? So this is the advantage of the modulation. Then we are having the classification of modulation. So we have studied this continuous wave modulation, that is amplitude modulation, and angle modulation. Angle modulation, we are having frequency and phase modulation. They are further being divided. Then pulse modulation can be further divided into two portions: digital modulation, that is pulse code modulation, delta modulation we have seen. And then we are having analog modulation, which is PAM, pulse width modulation, and pulse position modulation. This is pulse amplitude modulation also. So these are all digital forms. So analog communication and digital modulation, that is over there. So this is called as the digital communication. And these are some of the sorts of modulation. So we will be studying this amplitude modulation and this angle modulation, that is frequency modulation, phase modulation. Okay, so we'll be studying this, and hopefully in the coming classes. So types of modulation: AM, FM, and PM modulation. We can compare those signals. So the definition, as I told you in the last class, what is amplitude modulation? So the amplitude modulation is a technique of modulation in which amplitude of the carrier wave in accordance with the amplitude of the modulating signal. Remember this, in accordance with the modulating signal varies, right? In which the amplitude of the carrier varies in accordance with the amplitude of modulating signal. And in amplitude modulation, we have to keep frequency and phase as constant, right? So that is the basic one definition. So if you remember one, if you say learn or understand one of the definition, you can easily define the other definitions also. So amplitude modulation is a technique of modulation in which amplitude of carrier varies in accordance with the amplitude of modulating signal, keeping frequency and phase as constant. Remember this. So frequency and phase constant. Similarly, if you see the frequency modulation is a technique of modulation in which frequency of carrier varies in accordance with the amplitude of modulating signal. Now here, keeping the amplitude and phase as constant. So one of the parameter is being varying and the other two are being kept constant, right? Similarly, in phase modulation, the phase modulation is a technique of modulation in which phase of the carrier varies in accordance with the amplitude of modulating signal, keeping amplitude and frequency as constant. So if you understand one of the definition, that is amplitude modulation or frequency modulation, or say phase modulation, you can try to define the other modulation definitions of the other modulation technique also, right? Amplitude modulation is a technique of modulation in which amplitude of carrier varies in accordance with the amplitude of the modulating signal, keeping frequency and phase constant. And this is actually the wave that we expect, that is called as the modulated wave, right? So we are having both EC plus EM. So that is the carrier wave, sorry. So this is the carrier wave plus the modulating signal. Similarly, the frequency modulation, now here you are able to see the frequency is being varying according to the amplitude of the modulating signal, right? Modulating signal is nothing but which is the information that we need to transfer. The last one is the phase modulation. Now here also the phase changes, right? So it is not shown over here actually. So I have an animation where I can show you how the phase is changed, varied. So the phase reverses. So there is a phase shift of 180 degree as soon as there is a reversal of say the amplitude. So depending on the change in the amplitude, the phase also varies. So that is called as the three modulation techniques: amplitude modulation, frequency modulation, and say the phase modulation. We will be studying this in depth in the coming classes. So I guess today today it is over enough for today. So for now, I guess if you have any questions, we can try to resolve those questions. Do you have any questions? You can ask. Okay. I guess it is very clear on that note that you have understood what is actually the modulation and how many types of modulation and modulations are there, and what is the basic need of the modulation. So today we have studied this. I guess you have understood everything. And if you have any questions, you can put it on my chat box. Please go through my YouTube channel, watch, share, and like my videos. And please be attentive. If you have any issues, you can put it on the WhatsApp group as well as you can put it on the chats of my YouTube channel. Thank you very much for joining. Stay tuned to my channel, and we'll see you in the next lecture. Thank you very much for joining. Have a nice time. Stay home, stay safe, take care. Good day. Bye.